Alright, in this set of videos we're going to talk about the various types in C#, and we'll talk about the different operators. A lot of this will be very similar to C++ and Java, but I'm going to go over them anyway because, well, it's important to know how big they are, and what the different types are out there. So C# is just like C++ and many other languages, it is strongly typed, which means that when you create a variable, you have to define the type of the variable. And that tells the compiler how much memory to allocate for each one of those. So there's a number of basic primitive types. We have byte, sbyte, which is a signed byte, short, an unsigned short. We have an int, an unsigned int, long, unsigned long. We have a char, which is a single character. We have a float, double, and decimal. We have a bool. And then we have a couple of object types like string, object, and then there's the datetime class. So to declare one, all we have to do is just say int my variable, and that's it. Now we have a variable of type int. If we want to get the size of this, we can go ahead and print out the sizes of these, just like in other languages. Size of int, for example. When we run this, we will get out the size in bytes printed out to the console. So an int is 4 bytes in size. We can do this with any other built-in variable type. So we can say size of byte, for instance. And a byte is going to be 8 bits or 1 byte. If we want the size of an int and we want the size of an unsigned int. Now, both of these should be exactly the same value because, well, they're both 4 bytes in size. An int is a range of negative 2,147,483,648 all the way up to 2,147,483 or 2,147,483,647, and an unsigned is 0 to 4 billion some odd number. It's literally well, that's actually 4,294,000, or sorry, 4,294,967,295. So an unsigned int is double the positive value of an int, but an int has a negative value or negative range that you can go to. But both of these are going to be a 4-byte storage. There's also a long and an unsigned long. And this is going to be 8 bytes in size. And so this gets to a much larger number that I'm not going to bother trying to read out. But basically an unsigned long goes from 0 to 18 with a whole bunch of numbers after it. But it is going to be a 64-bit storage location, which is going to be 8 bytes in size. There is a short, which is used in some instances, short, and an unsigned short. These are going to be a 16-bit storage, which is going to be 8 bytes in size. So that means that a short will go from negative 32,768 to positive 32,767, and an unsigned goes from 0 to 65,535. So you'll see unsigned shorts probably used a lot more frequently. You'll get it in a lot of different locations. When I talked about networking, the number of ports would actually be an unsigned short number of ports, hence the 65,535. Let's see, what other types do we have? We have a char. A char is just going to be a single byte. Or actually, sorry, in C#, a char is 2 bytes as opposed to a single byte. The reason why it's 2 bytes is it can store Unicode characters. And in fact, it can store any Unicode character from, uh, well, any 16-bit single Unicode character. So it can go from all zeros to all Fs or anything in between. It can also store ASCII characters, single representations, but in C#, a char is 2 bytes as opposed to a normal 1 byte that you would get in C++, simply because it needs to store the Unicode characters there, the 2-byte Unicode. Talking about floating point numbers, you have 3 different types. You have float, you have size of double, and you have size of decimal. So you have 3 different floating point numbers that you can have. Float is going to be 4 bytes in size. Double is going to be, well, double that, which is 8 bytes in size. And decimal is going to be double a double, which is 16 bytes in size. Let's go ahead and run that. And so notice how we get the 4, 8, and 16. So depending upon how much precision you actually need, you could go with a decimal to get out to 16 bytes in size. You get quite a large number. That's 168 or 128-bit decimal value. According to my notes, it'll go from 1 times 10 to the negative 28th all the way up to 7.9 times 10 to the 28th. That 7.9 as opposed to 8 is because of 0. But yeah, it can go quite large. Let's see. The last primitive type that we really have, I'm using keyboard shortcut in JetBrains to comment and uncomment, which is Control/. If you just highlight the lines, Control/, that will comment or uncomment that highlighted section of code. So the last type that we have here is a Boolean. So a Boolean in C# is just a single byte, and it stores either true or false. Now, unlike C++, you could not tell it to print out a Boolean or cast it to an int or compare it to an int or something like that, because in C++, a Boolean could also be 0 or 1. In C#, it is only going to be true or false. So if you have a bool, that's what you're going to be storing in there.